Hey class, today we're going to be doing section 3.11 part 2 in our AP Stats course. We're going to be talking about sampling and bias versus error, different kinds of bias, and we'll look at an example for that. All right, so first let's talk about sample versus population. So a summary value from a sample is called a statistic. So if you have a sample, you take a sample and you get some sort of like average or standard deviation, those sorts of things, those are called statistics if they come from samples. While a summary value from a population is called a parameter. We use statistic to estimate a parameter. So a lot of the time it could be impossible, or it's just absolutely really difficult or time consuming or expensive to get information from everyone in an entire population. So a lot of the time we rely on samples, and hopefully we have good samples without bias, so that we can use what we gain, our statistics from our sample, to estimate what would have been seen if we had surveyed the entire population. It would be incorrect to say something like sample parameter. It doesn't make any sense. You're mixing two sample and population. You can't really do that. Or a population statistic again. So be careful. I spelled that wrong. Be careful when you use these terms. Just don't like mix them up or anything. All right, the corresponding symbolic notations for common summary values are, so for samples, we use X bar for the mean. We use S for the standard deviation. Size is N. And our equation of the least squares regression line would look like something like Y hat equals A plus BX. And we did linear regression, least squares regression lines in the last unit, so you're welcome to go back to my videos and watch that if needed. For a population parameter, our mean would be mu, so the Greek letter mu, sigma. The size, we use capital N, and be careful about the capital N because we also see that used for normal distributions. And then our equation would look something like Y hat equals alpha plus beta X. So it just looks a little different. We use a lot more Greek letters when it comes to population. All right, so bias versus error. We already learned that bias is a result of underestimating or overestimating a population parameter. It is the result of a poorly designed sample. A sampling error is different. It's another component of surveys. So sampling error does not imply a mistake was made in the sampling procedure and was avoidable if the person designing or conducting the survey was more careful. So it's not about us designing a bad sample or a bad survey or experimental design or gathering the data in a way that wasn't okay. That's not what sampling error is. Sampling error simply describes the natural tendency of randomly drawn samples to vary. So it's just a natural thing. If we take samples, some samples are, if we're truly randomly sampling, some samples are going to be representative of the population and some aren't. There's going to be natural variability, and that variability there is what that sampling error is. The difference in results between samples drawn from the sample population is called sampling variability. And while sampling error can be overcome by conducting numerous surveys, so more samples we have, the less error we have, and my highlighter disappeared here, bias cannot be reduced since it is the result of a poor design. So be really careful. We can reduce sampling error, but we can't reduce bias. If we just repeat the sampling method, we're just going to have more data that's bad. We're not going to fix it. So error is fine. We want to try to minimize our sampling error by taking multiple samples, but bias is not fine. So let's look at some bad sampling methods. The first one, so this is voluntary response bias. These are bad because the respondents, rather than the researcher, decide who will be in the sample. They often are biased towards those with strong opinions or those who are strongly motivated. In general, people with negative opinions tend to respond more often than those with equally strong positive opinions. So this is definitely one of the most commonly seen forms of bias, especially for like online surveys that we see in the media a lot. People who get to choose whether or not to answer the survey, you're going to see people answer more often if they feel really strongly about it and tend to see more strong in the negative direction than the positive. So don't trust those survey results. They definitely are all biased and not really worth much. All right, the next piece is convenience sampling. We see this one a lot too. In convenience sampling, we simply include the individuals who are convenient to access. Unfortunately, this group may not be representative of the population. So you see this a lot with people who are maybe standing in front of like a grocery store and they're like, hey, come, would you mind if I ask you a question? And they're like asking you and surveying you. That's convenience sampling. They're just standing in one spot and asking people who walk by. It's also not okay. It's a bad way of sampling. So biases of bad sampling methods. So this is what occurs if you use a bad sampling method. You could have non-response bias, which is, so hold on, non-response bias. So no survey succeeds in getting responses from everyone in the population. And those who don't respond may be different from those who do respond. So again, if you put a survey out there like online, you're going to get a difference between those who respond and those who do respond. So that's called non-response biases. People have the option of not responding. You get that bias there. Response bias is different. So be careful. I know non-response bias and response bias sound really similar, but they do have different meanings. So be really careful. Response bias refers to anything in the survey design that influences the responses. For example, examples of this include the tendency of respondents to tailor their responses to try to please the interviewer. For example, if I was asking my students who their favorite sports team was, and I was all decked out in like San Francisco Giants gear, some students might not want to hurt my feelings, and they might say that they like the Giants because they want to make me happy or something. So that would be response bias. Or we could see natural unwillingness of respondents to reveal personal facts or admit illegal activities. So this would be people lie. They really do. Or it could be with how the survey was worded. It could kind of be worded more towards one side than the other and not really neutral wording. So these are all examples of response bias. So let's look at a quick example. A survey will be conducted to examine the educational level of adult heads of households in the United States. Each respondent in the survey will be placed into one of the two following categories: does not have a high school diploma or has a high school diploma. The survey will be conducted using a telephone interview. Random digit dialing will be used to select the sample. So they tried to be good by saying that they were doing random digit dialing. They tried to do randomness there, but unfortunately, there's a lot of problems with this here. For the survey, state one potential cause of bias and describe how it might affect the estimate of the proportion of adult heads of household who do not have a high school diploma. So option one would be non-response bias. People without a diploma might work more hours. If you don't have a diploma, chances are a lot of people have to get lower paying jobs and thus have to work more hours to make enough money to support their family. And if they're working more hours, they thus might be home less than people with diplomas. So can't answer the phone. Oops, there we go. So in this case, and we always want to say if it's under or overestimating which part of the population. So for those without a diploma, it would be underestimating. So when you're explaining bias for AP Stats on the AP Stats exam, it's really important that you name the bias, you explain maybe like a reason why you would see that bias in context, and then tell me which direction the bias would put your results. So in this case, it would underestimate those without a diploma. So we would see less people in the survey results that say that they don't have a diploma than what really is happening in the population. Option number 2, we could have response bias. People might lie and say that they do have a diploma when they don't. Again, this would underestimate people without a diploma. So maybe they're ashamed or something about not having a diploma, so they lie and say that they do. Again, this would skew our results towards seeing more people with a diploma than what would really happen in the population. And that's it for today's lesson.